You look, let me go ahead and record this. If you see, if you're comparing the graph of y equals sine x and the graph of y equals sine of x minus pi over 4, then that graph is the same exact graph, it's just shifted right pi over 4. Okay, so that's what we're going to be looking at. So if you see a x plus a value, whether it's sine or cosine, you're shifting left. And if you see x minus a value, then we are shifting right. So that is just as it has always been all year long, all through Algebra 2, whatever classes you've ever had have been that way, right? Okay. So because this changes along the x-axis, we need to think about what our basic x-axis markers are. So that's why we have this, that's why we have this 0, pi over 2, and pi, and 3 pi over 2, and 2 pi, right? Those are our basic x-axis markers. If we take those basic x-axis markers, then we're either going to be adding or subtracting something to that. So here's what I need you to think about. So this is, it's not clear here, but this says sine of x minus pi over 4. This is the graph from up above that we're going to graph here. So I want you to notice what happens here. If we're graphing x minus pi over 4, that graph is getting shifted right 4. So that is why to each of our basic x-axis markers, we are going to add pi over 4. So you do the opposite sign of what it shows with those parentheses. Okay. I've already written in the y values here because if you notice, there's nothing changing. There's no vertical shift. There's no amplitude or anything like that. So nothing changing the y's. We're just adjusting our x's. This involves everybody's favorite thing in the whole wide world. We get to add fractions. So 0 plus pi over 4, we know that's just pi over 4. In some instances, we are going to have to deal with finding common denominator. So pi over 2 plus pi over 4, we've got to find common denominator. So 2 pi over 4 plus pi over 4. So this is 3 pi over 4. 4 pi over 4 plus pi over 4. And that gives us 5 pi over 4. Some people start to pick up and notice the pattern there. We're adding 2 pi over 4, which should make sense to you. All of these values, our special angles, are pi over 2 apart, or in other words, what's equivalent to pi over 2, which is 2 pi over 4. So that's one way to kind of finish this process, is think about the fact that you can add 2 pi over 4 to each of those. If you want to work through the math and adding those fractions, you can do that. You're just having to find your common denominator. So this would be 3 pi over 2 is equivalent to 6 pi over 4 plus 1 pi over 4 to get your 7 pi over 4, and so on. Okay? All right. So these problems are tedious because of all of the adding and subtracting and the common denominators. It's not that they're that hard, but it's tedious. There's a lot of just little work that you've got to do, okay? In terms of graphing, you do have to be careful there also because you've got to show that you know what a consistent spacing is for these. So quite honestly, the hard part about these is that you just want to make sure that you're drawing a consistent spacing. And I'm going to kind of give you some hints and some suggestions on that in just a minute, okay? All right, this is saying, if you look, we are starting pi over 4 units away from the origin. So you have to decide really how many boxes you want to use to represent that. My suggestion is you should think about that as 1 box away. So 1 little tick mark away. That's a distance of 1 pi over 4. So now to draw in our other hash marks, we need to go a distance of 2 pi over 4. So we need to go 2 hash marks away. So we're going to have pi over 4 here, and 3 pi over 4. Okay. okay? In terms of graphing the graph, let's go up. We need to show our up one and our over. The other kind of the trick or the thing to remember is that when you're actually graphing this, the tendency, we're so used to going straight to the origin or to the y-axis, and we're not necessarily going to be on the y-axis when we're graphing this. The first point we're going to graph, this is giving us the points that we're going to do. So at pi over 4, we're at 0. At 3 pi over 4, we're up at 1, and so on. So that's our sine curve. The only thing that's happened is it's just gotten shifted a little bit to the right there, right? It looks exactly the same. We didn't change anything else. That's it, right? Okay. Questions, thoughts on that? Okay, I'm going to come back and talk to you kind of about the spacing a little bit more in a minute. We're going to look at this next graph though first. Over here and look at this. If we use pi over 4 is one box, then the equivalent spacing that we need for pi over 2 has to be 2 boxes because it's going to be 2 pi over 4. So we need 2 boxes. So that kind of tends to be a general rule of thumb, okay? It takes practice with these, and they take a long while to work through. So that's part of the reason why I'm giving you time here in class to kind of work on this, work with somebody, ask questions of me, okay? But before we get going on that assignment, okay. On this one, if you notice, it's a plus pi over 3 here. So notice that means we are subtracting pi over 3 from each of those basic x-axis markers. Okay? So we're subtracting pi over 3 from each of those. So 0 minus pi over 3, that's pretty straightforward. You guys can handle that without even doing any writing down of stuff, but these others we're probably going to need to find common denominator and do that math. So pi over 2 minus pi over 3, so that gives us 3 pi over 6 minus 2 pi over 6. For the next one we're doing 3 pi over 3 minus 1 pi over 3, so we get 2 pi over 3. Common denominator here again. So we've got to multiply by 3, so we get 9 pi over 6 minus 2 pi over 6, so 7 pi over 6. Bless you, I think. I'm not sure. It kind of sounded like partial sneeze, cough. I'm not sure which. Okay. And then 6 pi over 3 minus 1 pi over 3. So 5 pi over 3. Okay. All right. Questions on that process? Okay, our y values are going to stay the same as is typical because there's nothing changing that. Okay, there's one other kind of key thing to look at when we are talking about problems here where what I want you to notice is that you've got some values here that are negative x values and some that are positive. So for me, I want to focus my attention on where it switches from going from negative to positive. Because when I start to draw my graph, I've got to make sure I've got my spacing consistent, okay? So let's scoot over a little bit farther. Okay, so if we compare these two numbers, this pi over 6 and the pi over 3, I want to look at and think about which one is the smaller unit, and pi over 6 is smaller than pi over 3. So I want to kind of think about how I want to move or progress, how many little tick marks, how many little boxes I want to move to represent 1 pi over 6. And in general, I tend to represent that with just 1 tick mark. So here's 1 pi over 6. So it's important to think about that. Pi over 6 equals 1 box. Because now I need you to think about this. To move in the other direction to show a consistent spacing for a negative pi over 3, negative pi over 3 is equivalent to negative 2 pi over 6. So it means we need to move 2 boxes this direction to show a negative pi over 3. Okay? Right? To move a distance left of pi over 3, that's equivalent to 2 pi over 6. So we've got to go two little boxes or 2 little tick marks before I draw my hash mark. So I want you to notice what the full spacing ends up being between these first 2 hash marks, because it needs to be consistent throughout. So if you notice, it's actually 3 dashes that we move. So 1, 2, 3 is going to be our next hash mark, next hash mark, next hash mark. Okay, so I've labeled my negative pi over 3, my pi over 6, my 2 pi over 3, there's my 1, there's my negative 1, and we're going to graph this here in just a second, okay? All right, take a look at that and think about that for a minute. Questions?
I'm so confused why you have to put the negative pi over 3. Like, why is it good? Is that just because, like...
Okay, I want to make sure I'm understanding your question. So if I answer your question, great. If not, you got to let me know. Okay, so to begin with, Sydney, when we look at the original x-axis markers, to decide how this graph is getting shifted, we have to look at what this is telling us. And that is telling us actually that it's a shift to the left, whatever this amount is. So remember, whatever this sign is, when you put your operation sign here, it needs to be opposite that sign. So we're shifting left pi over 3. So we've got to subtract pi over 3 from each of our basic x-axis markers. Okay? In doing that process, you're going to end up with at least one. On one of the homework problems you do tonight, most of your graph ends up being way over here to the left because of what you have to subtract. So you're going to end up having to rearrange where this y-axis goes on your graph based on kind of what these numbers end up being. I don't know, does that answer your question? Okay, all right. So we've got the 1 value, the 1 pi over 6, that's going 1 space to the right. Equivalent to 2 pi over 6, we have to move to the left. So that gives us a space of 3 in between each hash mark. And now we need to just draw in our basic cosine curve. So at negative pi over 3, we're starting up here at 1. Be careful. We're so used to drawing something on that y-axis that sometimes you accidentally add something in there. But our next point's at pi over 6, not at 0. And then we're down at negative 1. Excuse me. And then 0, and then up to positive 1 again. I will tell you, first period's already gone over this homework. They had this lesson yesterday, and they went over this homework today. And there were a couple of times when they drew their graph for homework, and they were like, something doesn't look quite right. You guys know what your basic sine and cosine curve should look like. You guys know what it should look like if there's an amplitude change to it. So if something looks a little bit off or wonky, with how you're drawing your graph, it's probably a spacing thing. So you've got to go back and check it. Okay? I want to talk to you just in general. I want you to think about the fact that if we use pi over 6 as one little space, that means 3 pi over 6, which is equivalent to pi over 2. And pi over 2 is our consistent spacing that we have from our unit circle, right? From our unit circle, we started at 0, pi over 2, pi, 3 pi over 2, 2 pi. All of those are a distance of pi over 2. So it should hopefully make sense to you that because we want to progress along our axis a distance of pi over 2, if we're using one box to represent pi over 6, then we're going to need 3 boxes in between our hash marks. Between hash marks. So that's kind of in general, okay? For most of the graphs that you see that have a pi over 3 and or a pi over 6, you're going to want to have a spacing of 3 little boxes between hash marks, okay? If we scoop back over to the other one where we had the pi over 4, I will tell you for pi over 4 and for pi over 2, the spacing tends to be 2 spaces. Because if you think about it, if we're using pi over 4, let's scoop, sorry, I'm jumping the gun. Other questions from this that you guys might have that you want me to kind of clarify first before we fill in that purple sheet, that reference sheet? Okay. Oh, I have that filled in. I didn't realize I had done that. It didn't clear. Wow. Okay. It's kind of personal preference what you choose to write in here. I'm going to clear this and go over this with you. It's kind of personal preference what you decide you want to write in here. How thorough you are with what you put in there. Come on. There we go. Okay. So we know the parent function. We know that's y equals sine of x. We know that it starts at the origin. It starts at 0, 0. Whereas the y equals cosine starts at 0, comma a. Right? So sine starts at the origin, 0, 0. Cosine starts at 0, a, either positive a or negative a, whatever that value is. Okay. It's up to you how thorough you are in terms of what you draw in here. I'm just going to draw the basic shape of that sine curve to help me remember that. You might need to draw in hash marks, tick marks, and hash marks if you think that's going to help you do that. Cosine curve, we know the basic shape of that also, right? I'm kind of doing both of these together because in terms of the information for period and amplitude and phase and vertical shift, it's all the same. Okay, so for the period, we know we do 2 pi over b, because b is this number out in front here of the x, so 2 pi over b. The amplitude, remember, is the absolute value of a. For our phase shift, I will not ever give you a period change and a phase shift on the same graph. You're going to have one or the other, adjusting your x-axis. I'm not going to give you both at the same time. Okay, so for your phase shift, you're basically going in the opposite direction of C, whatever you see for C. And for your vertical shift, you're going D units up or down. D units up or down. Okay. So day 2, you are learning tangent, cotangent, secant, and cosecant. Okay. And like I said, those graphs, I don't think I have them posted yet. I might. I don't remember when I posted them, but the tangent and cotangent, secant and cosecant are going to be on there. So if you're not here Thursday, for whatever reason, make sure you get those notes copied down so you have them for your open note quiz on Friday. Okay?